For more than 50 years, we've walked on the moon, studied its craters, and mapped nearly every ridge and shadow. And yet, there's one mystery that refuses to go away. Billions of dollars have been poured into spacecraft, rockets, and landers, decades of innovation in computers, sensors, and navigation. We've reached Mars, probed asteroids, and landed robots on comets millions of kilometers away. But here, on our closest neighbor, the moon, something keeps happening that scientists cannot fully explain. In the last few years, spacecraft after spacecraft from some of the most advanced nations and companies on Earth have failed in the very same way. Precision-guided landers, equipped with cutting-edge altimeters and lasers, smash into the lunar surface or topple into craters. It isn't just bad luck, it's a pattern. And here's the shocking truth. After all this time, scientists are admitting they may not have an answer. The moon, so familiar in our skies, is hiding something we don't yet understand. Something that has confounded computers, defied calculations, and left wreckage scattered across its desolate plains. Why is the moon resisting us? What secret is locked beneath its gray dust and ancient rock? And what happens when we try to send people back? Before we dive in, make sure you subscribe to stay updated on the mysteries of space, because tonight we're asking a question that could change everything we thought we knew. Is the moon hiding a secret we cannot explain? From the beginning of history, the moon has been more than just a light in the night sky. It's been a calendar, a compass, and a symbol of wonder. Ancient cultures saw gods and monsters in its glow. Poets wrote sonnets about its pull. For centuries, humanity has dreamed of reaching it. That dream became reality in 1969, when Neil Armstrong stepped onto the lunar surface with the words that echoed across the planet: "One small step for man, one giant leap for mankind." The Apollo missions made the moon a symbol of human triumph. 6 successful landings, 12 astronauts walking its surface, and a legacy that defined the space race. But then, silence. For decades after Apollo 17 in 1972, no human set foot on the moon. NASA turned its eyes to the space shuttle, to Mars probes, to deep space telescopes. The Soviet Union collapsed, China was just beginning its space program, and the moon was left alone, a relic of the past. Until now. We are living through a new lunar race more ambitious than Apollo and far more global. NASA's Artemis program is preparing to land humans at the moon's south pole. China has its Chang'e missions, already scooping up samples and planning a permanent base. India is aiming for Chandrayaan-4 after its partial successes, and private companies, from Japan's iSpace to America's Intuitive Machines, are competing to deliver cargo, rovers, and experiments to the lunar surface. Billions are being spent. The moon is no longer a trophy, it's a resource. Water ice at the poles, rare metals beneath the soil, strategic high ground for space exploration. But despite the technology and ambition, one problem has returned again and again. Landings keep failing. Crashes, tumbles, miscalculations. And the more we look at the evidence, the more it seems that the problem isn't just human error. The moon itself may be playing a role. Let's start with the numbers. In just the span of 2023 to 2025, more than half of all robotic moon missions have failed to land safely. That is an astonishing figure, especially when you consider that computers today are millions of times more powerful than what NASA had in the 1960s. In April 2023, Japan's iSpace attempted its first commercial lunar landing with the Hakuto R Mission 1 lander. Everything looked good until it wasn't. As the spacecraft neared the surface, the lander thought it was closer to the ground than it really was. It shut off its engine at an altitude of nearly 5 kilometers, believing it was safely touching down. Instead, it dropped like a rock, smashing into the moon. 2 years later, in June 2025, iSpace tried again with a lander named Resilience. This time, their technology was more advanced. The craft carried laser altimeters capable of measuring altitude down to fractions of a millimeter. But once again, failure. The lander's laser didn't activate until it was less than 900 meters above the surface, far too late. Traveling at 66 meters per second, it crashed into the moon with enough force to leave a crater 16 meters wide. Then came the American company, Intuitive Machines. Their lander, Odysseus, reached the lunar South Pole in February 2025. Unlike iSpace, their spacecraft did touch the surface, only to tip over on its side. Why? Because it came in too fast, with too much horizontal momentum, tumbling end over end before coming to rest like a fallen refrigerator. Once again, engineers blamed confusion in the laser altimeter system, which had suffered from signal and noise distortion. India's Chandrayaan-2 in 2019 faced the same cruel fate. As its Vikram lander descended, a software glitch caused it to deviate from its planned trajectory. Despite last-minute corrections, it slammed into the moon. Different nations, different spacecraft, different years. Yet one eerie similarity: instruments misreading the moon's surface and computers making catastrophic mistakes. And here's the part that haunts engineers today. Back in the 1960s and 70s, Apollo landings, using computers less powerful than a pocket calculator, succeeded 6 times. Neil Armstrong's landing in 1969 nearly failed. The onboard computer overloaded with data, triggering alarms just minutes before touchdown. But Armstrong, a trained pilot, took manual control. He guided the lunar module over a crater, finding a flat spot with only seconds of fuel left. Human instinct saved the mission. Every Apollo astronaut trained extensively on rocket-powered simulators, practicing worst-case scenarios. The computer assisted, but the pilot decided. And that human adaptability may have been the difference between success and failure. Modern landers, in contrast, are fully automated. Computers make every decision. And while they are brilliant at calculations, they cannot improvise when conditions turn strange. As one NASA engineer put it, the moon is like black ice. Your instruments tell you one thing, reality does another. So what's really going on? Scientists and engineers have floated several theories. First, reflectivity. The moon's surface isn't uniform. Some areas are brighter, others darker. Lasers used for measuring altitude rely on light bouncing back. If the surface is less reflective than expected, the signal gets distorted, confusing the lander's computer. Second, lunar dust. The moon's regolith is a fine, powdery substance that clings to everything. When a lander descends, its rocket plume kicks up dust clouds that can blind instruments in the final seconds. Apollo astronauts saw it firsthand, descending into what looked like a sandstorm, trusting their instincts rather than sensors. Third, mascons, short for mass concentrations. These are dense regions buried beneath the lunar crust, discovered during the Apollo era. They warp the moon's gravitational field, subtly pulling spacecraft off course. A few meters of deviation on Earth is nothing. On the moon, it's the difference between a safe landing and total destruction. Finally, software itself. Complex algorithms control descent speeds, engine burns, and sensor data. A single line of faulty code, or an assumption about conditions that turns out to be wrong, can spell disaster. The truth is, it's probably a mix of all these factors. The moon is far stranger than we imagined. This has sparked a debate at the heart of space exploration. Should we trust computers, or should humans always have the final say? Computers are faster, more precise, and tireless, but they are rigid. They cannot adapt to unknown. Humans, on the other hand, make mistakes, but they can improvise. They can see when something looks wrong and act. NASA's Artemis program plans to put astronauts back on the moon by 2026. And many engineers now believe that giving crews the power to override computers, just like Apollo, may be essential to success. But what if all of this isn't just bad luck or bad coding? What if the moon itself is hiding something deeper? One possibility lies beneath the surface. Mascons, those mysterious mass concentrations, are stronger and stranger than we thought. Some scientists now believe they're relics of giant asteroid impacts billions of years ago with dense metal cores still buried under the lunar crust. These hidden structures warp gravity so strongly that they can literally pull spacecraft off target. Another theory involves electrostatic dust. Unlike Earth, the Moon has no atmosphere to ground electric charges. Solar radiation causes dust to become charged, floating above the surface like a ghostly haze. Instruments relying on lasers or radar may be thrown off by these invisible storms. Apollo astronauts reported seeing a strange horizon glow on the Moon, possibly this dust-scattering sunlight. And then there's the possibility no one wants to discuss: silence. Agencies, companies, and governments may be downplaying these failures. Admitting that the Moon itself poses unpredictable dangers could spook investors, rattle politicians, and jeopardize billion-dollar programs. Here's the haunting fact: these problems have been repeating for decades. Surveyor 3 in 1967, Chandrayaan in 2019, iSpace in 2023, intuitive machines in 2025. The pattern is undeniable. And yet the Moon is only 384,000 kilometers away, far closer than Mars, far simpler than an asteroid mission. If it is this difficult to master, what does that say about our readiness for deeper space? What do you think? Is this human error, or is the Moon hiding something deeper? Let us know in the comments below. Despite the risks, humanity isn't slowing down. The stakes are simply too high. NASA's Artemis 3 mission aims to land astronauts at the Moon's south pole. Unlike Apollo, this isn't about flags and footprints. The target is water ice. Locked in permanently shadowed craters, this ice could be turned into drinking water, breathable oxygen, and rocket fuel. It is the key to sustaining life beyond Earth. China's Chang'e 7, launching later this decade, has the same goal. Their mission: land near Shackleton Crater and survey resources for a future lunar base. Beijing has already announced plans for a permanent outpost by the 2030s. Private companies are moving fast too. Firefly Aerospace scored a success in 2025 with its Blue Ghost lander, which used an AI-powered system that mimicked human vision. Cameras identified safe landing zones in real time, making decisions like a pilot would. It was a glimpse of a future where artificial intelligence could match, and maybe surpass, human adaptability. But here's the catch: if these mysteries aren't solved, long-term plans for mining, habitation, and exploration could fail before they even begin. A single crash costs hundreds of millions. A failure with humans on board could end lunar ambitions for a generation. Some scientists even speculate, what if these anomalies are not random at all? What if they are the natural defenses of a world not meant to be colonized so easily? It's an unsettling thought, but one worth considering. For decades, we've looked at the Moon as a silent, dead world, our closest neighbor, a stepping stone to Mars, a training ground for humanity's future. But what if the Moon is more than that? What if it is the ultimate test, not just of our technology, but of our adaptability, our ingenuity, and our will to survive? It has resisted our machines, defied our computers, and humbled our ambitions. Yet it still calls to us, pulling us back with a mystery we cannot ignore. The Moon is hiding something we cannot explain. The only question is, will we solve its mystery before it stops us? If you want to keep exploring these hidden truths with us, subscribe and join the journey. Because the next time we return to the Moon, it might not be just another small step. It could be the moment that decides whether humanity truly belongs among the stars.